Today in this tutorial we are going to learn how to make line plot in biological and biomedical research. Visualizing data properly is extremely important. Many figures in research papers only show mean values which can hide important biological variability. In this tutorial we will build a publication ready visualization plot in R, and we will show raw experimental measurement, group mean, variability using standard deviation, and we will compare sepal length and sepal width across species using the classic R dataset IRA, and we will visualize the data with ggplot2 and using the tidyverse and different packages. By the end of this tutorial, you will understand not only to code but also why this type of figure is scientifically meaningful. So this is the aim today in this tutorial. Let's directly jump into our code. So our aim is how to create a line plot, and we are here loading at the libraries. It's like a tidyverse library, read R, read Excel, PLOS, and janitor. We just simply run the code, and then we can see our libraries are run. So what is doing data manipulation, reshaping the data, and data visualization are done by tidyverse, and dplyr for processing the data, including the tidyverse, and ggplot2 we are also want here. So I will just write in a library ggplot2 and again run the code. So we have here all our libraries. Now second step is our loading the iris data. It's available in the R, so you don't need to find any new data. You just simply call this data from your base R, and we run here data. And as we see here in iris data, we have sepal length, sepal width, petal length, petal width, and species. And in biological studies, such measurements are often used to understand morphological differences between species. And here we will compare two traits, sepal length and sepal width. So now after loading a data, we comes to our third step is called convert data from wide format to long format, because as you see the iris data in a wide format, and we need to little bit change this data into a longer format. Here we are using our library tidyverse, which we already loaded, and here is our iris data, and we are using a function pivot longer. In a pivot longer, we are saying please select the column from iris data, sepal length and sepal width, and append them. This column in a one group is called measurements, so names to measurement and values to the values. It's a very simple code. You can check. And pivot longer. Pivot longer is more used code in to transform the data from wide to a longer. So we run the code here, and as we said here, head iris long because we make it converted it to a long format. So we can see here we have a petal length and petal weight. Species is setosa. Species are column here. Our new column is a measurement where we have both sepal and sepal weight and values. These two columns are our new. So this structure allows us to plot and multiple biological variable in a single graph. So now we will inspect the data. Next step, calculate summary statistics first, because we need to check the summary. So we have our iris long variable. Here we said please group by species and measurement and summarize the mean values as a mean and standard deviation as SD on the values. And we are saying please dot group equals to drop. So after grouping the data, please spill back again, and this one we are saving as a iris summary. So when we do here, and we can see here we got a summary of see for setosa, sepal length is like a mean value 5.01, standard deviation is 0.35, for sepal width 0.379, and like for vesicular and virginica. This is our summary. We are going to use this summary in our plot. So now the next step. So here we have a geom line, and in a geom line we are using data iris summary. As said, on x-axis species, y-axis mean value, group by measurement, and color by measurement. And the line width we are saying 1. Inherit aesthetic equals to false. We don't want that it will use the upper aesthetic geom jitter. No, we want the geom line aesthetic. So we says here please use this aesthetic, not the first one. After doing that, we say another geom we are using, I call it geom point, and in this geom point we are also saying please use the data iris. Aesthetic is the same as on x species, y equals to mean, color equals to a measurement, and size of the geom points is a 3, and inherit aesthetics equals to false. After that, we are adding here the geom error bar, and again we are using the same data iris summary. And aesthetic, we are saying an XPC because when we are using a standard deviations for error bar, so we say y mean equals mean value plus or minus SD value, and color equals to a measurement. Width of the error bar is a 0.15, and the same inherit aesthetic equals to a false. And here we use a theme classic, and in the theme function we are saying listen dot position on a. So now after doing this, we just run this code and we will see how the output will come. As we can see here, our output is really nice, good figure, a publication ready figure. And we can say here, we got our first aesthetic as a geom jitter here. Second aesthetic was our line. So it's connecting the line, all the points. And third was geom point. Their points are here with the size 3. And the fourth geom was our error bars. So positive and negative error bars we are getting here. And class will remove all the backgrounds and just give us a very nice and beautiful x and y axis, and the legend as we told on the top. So we got here on the top. So from like this, we prepare a line plot using a ggplot. So this was all for this short video. If you find this video useful, consider to subscribe the channel for the new feature. Thanks for the watch.